to another segment. In our last lesson, we learned about irregular shapes and how you can find the area by measuring a whole unit and then partial units, using those partial units to make whole, and then adding the whole and partially whole units to create the area. Pretty cool. And also a little challenging, so I give you props for giving yourself that big challenge. And now we're going to use our knowledge from our lessons about area and how we learned the distributive property, how we learned about square units, to the irregular shapes, and helping us understand more about perimeter and area. Do you remember perimeter? We haven't talked about perimeter in a long time. Remember, perimeter is that fence line. So we're talking about all the way around the shape, that perimeter. Remember, in perimeter, we add a side plus a side, a side, and a side. By adding up all those sides, or our fence line, we get our perimeter. And then to refresh your memory on what area is that measure of space inside a shape. So we're not looking at that fence line, that's perimeter. Area is that inside of the shape, all of those square units that make up an area. Funny. And then we talked about how area is measured by multiplying our length times our width, or by simply counting all of the square units within the shape. So now we're going to apply this knowledge to help us understand and recognize how some shapes can have different area, but the same perimeter. Interesting. But we're going to find that out today. And let's go over to my desk because I want to show you how this works. How to find different area, but the same perimeter. Let's check it out. Come on. Okay, so now that we're back at my desk, I just want to explain how you can have a different area, but a same perimeter. It's honestly pretty crazy. And these examples that I have on here will show you exactly how to find that. Well, here I already found our length and our width for each of the shapes to find the perimeter. And remember, perimeter, we're just going to add up all of the sides. So let's look at our first one. So we have perimeter. We're going to look at yellow. So we have a length of 8. And then we have a width of 3. So I added 8 and 3. And then I'm going to add our other length, which is also 8. And then our other width, which would also be 3. And so we add 8 plus 3, 8, 9, 10, 11. Then we're going to add 8 times 3 again. We get 11. So our perimeter equals 22 because we add 11 and 11, and 11 plus 11 is 22. And we're going to say 22 centimeters. And then, let's see, let's try this one out. So we have a perimeter with a length of 1 plus a width of 10 plus another length of 1 plus another width of 10. So let's add 10 plus 1, which is also 11, and then 10 plus 1, which is another 11, and then perimeter is adding 11 and 11, and 11 plus 11 equals 22 units or centimeters. Now let's look at our orange one. What is my length for this shape? Exactly, we have a 9 as our length. What is our width? 2, nice. Okay, and then if we have 9 as our length on that side, 9 is going to be there for our length again, and our width is also going to be 2. So now we're going to add 9 and 2. So we add 9, 10, 11, we get 11 again there. And then 9 plus 2 is also 11. And then if we add 11 plus 11 together, we get 22. And I'm going to add my units there. All right, and then let's look at our blue shape. Let's see. So what is our length on that shape? 4, nice. And what's our width? 7, okay. So what's my length again? 4, nice job. And what is my width again? 7. All right. So now we're going to add 7 and 4. And what do we get? 11. All right. And then let's add these again. We have 7 and 4. And we also get 11. So our perimeter here is also going to be 22 centimeters. All right. Do you notice how each of these shapes look totally different? But look, they all have the same perimeter. Isn't that crazy? Now, I'm kind of curious. Do you think that they have the same or the different area? I don't know, but I think we should find out. So I'm going to grab my pink pen and we're going to do the exact same thing, but with area. So remember, when we talk about area, we're going to multiply our length times our width. So for the yellow problem, we have a length of 8. And we're going to multiply that by our width. And our width here is 3. So our area is 8 times 3. Now what is 8 times 3? Good, 24. All right, but 24 what? What do we put for our area for our answer? Good, we're gonna write square units, but in this case, our unit is centimeter, so I'm going to write square centimeter, or cm for short. Okay, and then if we look at the pink side, we're going to find the area by looking at the length and the width as well. So we have a length of 1, and then we're going to multiply that by our width, which is a width of 10. So now 1 times 10 is, good, 10 what? 10 monkeys? 10 butterflies? 10 square centimeters. All right, and let's move on to orange. So let's see. We need to find our area, and our area is our length times our width. Our length is 9 centimeters. And multiply that by our width, and our width is 2 centimeters. And so 9 times 2 is 18. So 18 square, and our units are centimeters still, so square centimeters. All right, and then for our blue square, we're gonna find the area by length and width. Our length is 4, and our width is 7. All right, so then 4 times 7. What is 4 times 7? Good, 28. Square centimeters. All right, so now that we have found our perimeter in blue and then our area in pink, do you notice any similarities or differences? Let's take a minute just to look at this. Do you notice any similarities or differences in the answers of our perimeter or area for each of these? Exactly. Yeah, so each of these have a perimeter of 22. Do you see that? And then what do you notice about the area? Are they the same or are they different? Exactly, they're all different. The area of the yellow square or rectangle is 24 square centimeters. And then the area of the pink rectangle is 10 square centimeters. The rectangle of the area of the orange rectangle is 18 square centimeters, and the area of the blue rectangle is 28 square centimeters. So therefore, this is an example of what it looks like to have the same perimeter, but a different area. Pretty cool, right? So now we're going to go to our workbook page and we're going to work on some more practice problems. So now I have my workbook page 14-8. Remember, you can look at this online or you can print it out. It's totally up to you. Either way, you're going to need some type of scratch paper, or you can print out a grid, or if you have graph paper or grid paper, you can use that as well. So I'm going to model how to do number 1, and then together we're going to work on number 4. So first I'm going to read the directions. For 1 through 3, use grid paper to draw 2 different rectangles with a given perimeter. Tell the dimensions and area of each rectangle, and then circle the one that has the greater area. Okay, so here it tells us that we need to draw 2 different rectangles with this same perimeter, which is 12 meters. So for that, I'm just going to grab a little marker here and I'm going to make a rectangle with the perimeter of 12 meters. And then to do this, I'm just going to think about what plus what plus what plus what equals 12. I'm going to write that here. So perimeter, we're looking for a side plus a side plus a side plus a side. So I'm going to need to figure out what to put here in order to make 12. But remember, we're doing a rectangle, so that means 2 sides must have the same unit of length, and the other 2 sides must also have the same unit of length. I know that if I add 3 plus 3, I get 6, and I know that 6 is half of 12, so I know that I can just do another 6. And so 3 plus 3 plus 3 plus 3 is 12. So now I'm going to draw that out on my grid. So I have 3 plus 3 plus 3 plus 3. All right. So now I made like a box where I have 1, 2, 2, 3. So I have 3 meters on this side. I have 3 meters on this side, 3 meters on this side, and 3 meters on this side. Okay, and then I also need to find another example of what can make a perimeter of 12 meters. So I'm going to have to find something else where I add a side plus a side plus a side plus a side in order to get 12 meters as a perimeter. So I also know that 10 plus 2 is an example of 12. So 10 plus 2. So I broke that down. And then I know that I can split 2 in half by adding 1 plus 1. And then I know I can break down 10 by adding 5 plus 5. So if I add 5 plus 5 plus 1 plus 1, I'm going to get 12 as my answer. So now I'm going to write that, or I'm going to draw that here. And I'm actually going to use a different color. I'm going to use pink. So if I have a side of 5, we'll make that my length. We have 1, 2, 3, 4, 5, and we have a length of 1, or a width of 1. Okay, so that's that. And then we have 1 box for our width, 1 meter, and then we have 1, 2, 3, 4, 5 meters for the length, another 1 for the width, and another 5 meters for the length. So now I need to see, let's see. So I drew 2 different rectangles with a given perimeter, and then now
I also told the dimensions of the rectangles. And now I need to find the area of each rectangle and circle which one is greater.
Alright, so now since I have labeled the dimensions of each side of my shape and found the perimeter that way, as well as working up here and kind of using some scratch paper to figure out those problems, now I'm going to find the area of each rectangle and circle the one that is greater. So for the yellow, I'm going to just write my area formula so I don't forget. Area equals length times the width. And so my length of the shape was 3, as seen here and here. And then we had a width of 3 as well. So here I'm going to multiply 3 times 3. And 3 times 3 is 9. 9 square units? Nope, it tells us the units. It's meters. So 9 square meters. Okay. And then for the pink one, we're going to also write our formula out. Area equals length times the width. Our length is 5. And our width is 1. So our area equals 5 times 1. And 5 times 1 is 5 square meters. Now, if you were confused of how to get 9 square meters, remember that when we multiply the length and the width, that tells us how many boxes are inside here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, if you don't necessarily want to use this equation, you can also use the counting on strategy and label your boxes, because that will also help you to find the area. So basically, either this formula or counting on is going to help you find the number of all the boxes with inside this figure. All right, and so now we need to figure out which of these is greater. Is a 9 or 5 greater? Exactly. So 9 is greater. And that's all we have for that problem. And now we're going to walk through number 4 together. Just going to flip over my page here. All right. And so the directions for this one say, for 4 through 6, describe a different rectangle with the same perimeter as the one shown. Then tell which rectangle has the greater area. Okay, so let's see. So we are going to describe a different rectangle with the same perimeter. So that means we're going to have to use different numbers than the 4 and 4 here. And then we're going to tell which rectangle has a greater area. So I'm just going to redraw this out here so I can just show my work. So I have split in half, split in 2 more. All right, so now I have 4 centimeters and 4 centimeters. Okay. And so first I need to find the perimeter of this figure to know the perimeter that I need to create for a different rectangle. So let's see, I had 4 as a length on this side and 4 as a width on this side. And I'm going to count. I have 1, 2, 3, and 4 as a length on this side. And then I have 1, 2, 3, and 4 as a width on this side. So to find perimeter, I'm going to write P for short. We're going to add 4 plus 4 plus 4 plus 4.
I'm going to break that down by adding 4 plus 4. 4 plus 4 is 8. And then I'm going to add 4 plus 4 on this side, and I also get 8. And then I'm going to add those two 8s together, and I get 16. And since this is the perimeter, I'm just going to write centimeters. And so now I need to find another item that's going to have that perimeter of 16. So now I need to figure out how I can do that. Well, I can just kind of start like this, like the last time. I have 16. And so I know that to make 16, I can also have 10 plus 6, right? And now, can I break these in half? I sure can. I can add 5 plus 5 to get 10, and then I can add 2 plus 3. Oh, no, 3 plus 3. I was multiplying there. You can add 3 plus 3 to get 6. And so now, to add all of these up, 5 plus 5 is 10, 3 plus 3 is 6, 10 plus 6 equals 16. So, this can be my new shape. So I'm going to draw myself a shape, and I'm going to have 5 here. And then I'm going to have 3 as my length. So we have 3 centimeters and then 5 centimeters. And then 3 centimeters and 5 centimeters. And now I need to find which rectangle has the greater area. So I'm going to use a different colored pen to find the area. So I'm first going to look at this figure and find the area of this one. So we remember that area equals length times our width, right? So we're going to take our length of 4, area equals length of 4, times our width of 4. We're just going to multiply those. And 4 times 4 is 16. But we're going to finish it off as 16 square centimeters. All right, so there's one. Now we need to find the area of this figure. So we have our area equals our length times our width, that's our formula. And then we're going to find our length, which is 3. Area equals 3 times our width, which is 5. So 3 times 5 is 15 square centimeters. So now, which one of these is bigger? Which one of these has the greater area? 16 square centimeters or 15 square centimeters? Exactly, it's going to be our 16 square centimeters.
You guys did a great job with working through those problems. It's pretty interesting to see how something can have the same perimeter, but a different area. So I want you to think, how can we use this in our lives beyond the classroom? Is there a way that you can do this at home? Could you find a couple objects and maybe measure them with a ruler and see if they have the same perimeter in a different area? I think you can. It might take a little bit of searching, but I think it's definitely possible. Well, I am so proud of you guys for taking on another challenge today. I hope you had fun learning about it and know just a little bit more about perimeter and area. Remember, if you have any questions at all, feel free to contact me or Miss Johnson, and then just let us know in the comment section or during our Zoom meetings if you need any clarification, because I do know that perimeter and area can be a tough topic. But just to review, perimeter is that fence line around an object, and we're going to add up all the sides of our perimeter. Okay, so for perimeter, we add. And then for area, we're looking at the space inside a shape. So we're going to multiply our length times our width, and that's going to tell us the inside of our object or figure. And now since we're done with our lesson, I do have a trivia answer for you from last time and a new question for you to answer. So our last question was, what is 309 rounded to the nearest hundred? What is 309 rounded to the nearest hundred? And our answer is 300. All right, and now I have another question for you, and it's about animal science. And here it reads, true or false? A camel's hump is primarily used to hold water. Do you think that's true or false? That a camel's hump is primarily used to hold water? I don't know, but I guess we'll find out in the next lesson. Until then, thank you for tuning in to yet another Wisdom Window segment. I'm glad you were here, and I hope to see you again soon.